ಅದೇ ಶೇರ್ ಕೊಟ್ಟಿದಾರ ನೋಡಿ, ಶೇರ್ ಇಂಡಿಲ್ ಕೊಡಿ ಪ್ರಿವಿಯಸ್ ಫಸ್ಟ್
ಇದೆ ಅಲ್ವಾ?
ಇದಲ್ಲ, ಅಲ್ಲಿದೆ ನೋಡ್ಲಿ. ಅದೇ ಇದಾಕ್ಬಿಟ್ಟು ಫುಲ್ ಸ್ಕ್ರೀನ್ ಇದೆ, ಫುಲ್ ಸ್ಕ್ರೀನ್ ಅದೇ ಸ್ಲೈಡ್ ಶೋ ಅದೇ ಹಾಕ್ಬಿಟ್ಟು ಕೇಳಿಸ್ತು.
ಅದೇ ಇನ್ನೊಂದು 2 ನಿಮಿಷ ಬಿಟ್ಟು ಮಾಡ್ತೀವಿ. ಇದ್ರ ನಮ್ಗೆ ಎಷ್ಟು ಜನ ಇರ್ತಾರಂತ ಇಲ್ಲಿ ಶೇರ್ ಮಾಡ್ತಿರ್ಬೇಕಾದ್ರೆ ಗೊತ್ತಾಗೋದಿಲ್ವಾ? ಎಲ್ಲಿ ಎಲ್ಲಿ ಗೊತ್ತಾಗ್ತದೆ? ಮೇಲ್ಗಡೆ ಇಲ್ಲಿ 200 ಆದ್ರು. ನೋಡಿ, ಇನ್ನೊಂದು 5 ನಿಮಿಷ ನೋಡಿ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬಿಡ್ತೀವಿ. ಓಕೆ.
ಕೇಳಿ ಯಾರು ಸ್ಕ್ರೀನ್ ಶೇರಿಂಗ್ ಬಂದಿದೆ, ಅವ್ರು ನೋಡ್ತಾ ಇದ್ದಾರೆ.
ನಿಧಾನ ಜಾಯ್ನ್ ಆಗ್ತಾ ಇದ್ದಾರೆ ಸರ್.
ನಾನು 2:40ಗೆ ಸ್ಟಾರ್ಟ್. ನೀವು ಯಾವಾಗ ಹೇಳ್ತೀವಿ
Dear friends, am I audible now? Any one of you can tell me, am I audible? And
Yes, sir. Yes, sir.
is,
Audible, sir.
is slides are seen? Sudarshan sirs? Sir, whether the slides are seen?
Yes, sir.
Okay. And now I request Dr. Sudha, welcome Dr. Sudarshan sir, and I request him to present his presentation on ethical considerations in health science research. Please attentively listen to this because it's very important. If you are selected by the internal and external validators for presenting the things in the expert committee meeting, first thing we see before you go for the ethical presentation, first thing we see is whether ethical clearance is there or not. Keeping that in view, this session is being placed here. Please attentively listen to this. I welcome Dr. Sudarshan sir and request him to go ahead with the presentation. Sir, namaskar sir.
Thank you very much. And I will start my presentation, and it is a post-lunch presentation. I am fully aware. And as Professor Ramchandra Shetty has put it across, that usually ethics committees and ethics scrutiny are considered as roadblocks, but certainly not. For any research to be conducted, now it is mandated by law that it shall have a prior approval of a registered ethics committee. So hence it is very important. And in that context, I take that all of you are prospective principal investigators, and I make this presentation to all of you. So ethics and health sciences research. What is ethics? I will not go into very fundamentals. I'll just quickly read it. Ethics or moral philosophy is a branch of philosophy, a science that involves systematizing, defending, and recommending concepts of right and wrong conduct. So it is a simply right and wrong conduct of research here. Means there are set norms of how to do a research from an ethical perspective. Those will be presented here. And also another definition is moral principles that govern a person's behavior or conducting of an activity. Here it is a research study. What are the four cardinal principles of ethical research? One is autonomy. That is, you do research on usually people, maybe an individual in a hospital setting or a group of patients, or a group of people in a community setting, or it could be on animals. So whatever it is, I take it here as clinical research, human research. I'll give examples from human research. So basically, you must have respect for persons because particularly in the hospitals, clinicians, when they come to you as a patient and they come to you for treatment. But you will take them into your research, of course, through various procedures. And then the patient becomes a participant. So there is a difference between a patient and a treatment and a participant and a research process. So this must be kept in mind. So when you take a patient to a research study and convert him to a participant, you will have to accord due respect to these subjects or participants, which is autonomy. Next is beneficence. That is, whatever benefits that come from your research, it should primarily go to the participants. So please remember that if there is anything favorable, anything positive, anything beneficial, should first go to the participant. Next is non-maleficence. That means avoid harming the subjects. Of course, there may be certain procedures which may carry some risk and some uh, chance of an harm, but that should be kept minimal, and there is a way of risk benefit analysis that will be done by you as a PI. I will not go into the details. So avoid harm to your participants. And justice. When you choose your participants, you have to be fair. So that's why randomization is done, so that you do not choose participants of your choice favorably. So justice is fairness in selection. So these are the four cardinal principles of ethical research: autonomy, beneficence, non-maleficence, and justice. So as PI, of course, all of you are expected to have a valid GCP certificate, because it is a requirement which your ethics committee will ask for it. And there all these things will be covered a little more in detail. Now, what are the four pillars of ethical research? Most important is you, the principal investigator. If you are okay, the research is okay. So 90% of the problems can be addressed by the principal investigator, who is well conversant with both science of research and ethics of research. Now, next is the regulator, internal regulator, that is at the institutional level. For humans, there is institutional ethics committee for humans, obviously, and for animal research, there is institutional animal ethics committee, IAEC. They are the internal regulators, because by law now they are established in the institutions as per the relevant national regulatory guidelines. Now, next pillar is the institution itself. See, the institution should have an ecosystem that favors and promotes research. Of course, now national regulatory bodies like NMC, Dental Council, and Nursing Council, and others, they are giving more and more emphasis on conducting good quality research and more research. And this is now, over a period of time, is assuming importance, and both in terms of number and quality. And lastly, the national regulators. One is the Drugs Controller General of India, that is the DCGI, the office. The organization is Central Drug Standards Control Organization. So that's one. Otherwise, Department of Health Research, ICMR, DHR. So this is for humans, and for animals, it is CCSCA, which is in the Department of Animal Husbandry now. So these are the ones which the national regulators for human research and for animal research. Now, coming to the institutional research and settings, see, when you are doing a research, you must also know what is your research setting. Now, broadly, there are four in number. One is the clinical research, which is done in the hospital settings. Obviously, it is a controlled clinical setting, and the participants are clinical research is done in the hospital settings. Next is the public health research or community health research, which is done in the community or the population settings. And the third one is the animal research, which is done in the laboratories, and also the in vitro research that is also done in the laboratories. Now, what are the 12 general principles of ethics of human research? I will quickly run through because this is very important when you are framing your research protocol, which was told in the morning by Dr. Anurag Kurpad. So he has made a reference to me also. I will try to address those issues as far as possible. So first is essentiality. You see, most important is this research study really needed? Just because RGHS is giving funds and we want to give a research proposal, our institution should come on the research board of RGHS. We should be seen. No, that should not be the criteria. So you should find out. Anyway, it will be screened by internal evaluator, external evaluator, and ultimately here we will really see, is it really needed research, because we will be having our own search engines, and we will see whether it is a repetitive study. So in that case, we may not consider it favorably. Now, next is the participation of the participants or the subjects voluntary. Of course, this will be seen by your institutional ethics committee at university level. We will not be able to see all the minute details. So your informed consent document and your study protocol from ethics perspective is usually screened initially by a scientific scrutiny committee or a scientific advisory committee at the institutional level. Then it will be again checked at in the institutional ethics committee, and then approval is given and a certificate is given. I will come to that subsequently. Now, next is non-exploitation. Is your research in any way harmful to the subjects, harmful to the patients, or harmful to the animals? So there are ways and means of looking into this. In humans, I am familiar. So I come from the medical background. So it is a risk-benefit analysis, and there are ways and means of doing a risk-benefit analysis. It will be known. Generally, the basic medical pharmacologist and the clinicians, they do this, and they are usually trained in the ethics committee, and they do that. Now, our social responsibility. Say, some research, particularly related to sexuality and human reproduction, they need to be handled very carefully, because whether it is going to affect any social harmony in the population or at the family level, this needs to be kept in mind. Privacy and confidentiality. Now, privacy is when you are doing interviews, when you are doing examination, you will ensure that there is sufficient privacy that is given to ensure the dignity and decorum of the subject, and the person is not offended. And whatever data and information which you collected should be kept confidential, anonymized, and no personal identifiers are available to anybody beyond you. Risk minimization, of course, same thing, no harm or whatever minimal risk that should be risk and benefit has to be clearly checked, and if it is acceptable, then the study is permitted. Now, whatever benefit, as I told you, you should go first to the participants, next to the society, next to the science, and some even say humanity. So humanity, science, and society, they come later. First is you have enrolled the participants, they have trusted you. So you should ensure that no harm is done and benefit from your research goes to them first. Now, professional competence. See, this we see, it is seen at the scientific advisory committee in the institution. Sometimes because it's all familiarity, sometimes breeds contempt, it may get missed there. And then the ethics committee, because the chairman and certain members are from outside, they will see the professional competence means we see in terms of their qualification and experience. That's all. PI, co-PI, sub-investigator. And regarding the institutional ethics committee, their competence and their suitability is checked by the regulatory bodies. And then only the ethics committee is registered with the name of the person. So that is very important, because we would have given the CV, and based on our CV and any other processes, they give approval to the registration of the ethics committees at the national level, whether it is CDSCO or DHR. So these are the two committees, and for animal research, it is the CCSEA in the Department of Animal Husbandry. Now, next is the institutional arrangements. See, any research that shall be conducted, there shall be good facilities for research, and patient charter. Patient charter is, it tells that what are the benefits of participating in a research, and all those voluntariness, consent, everything is displayed in research facilities. When I go for NABH assessment, so I look into this participant charter in those NABH accredited ethics committees. Transparency and accountability. See, one is best way of transparency is to put it in the public domain. I will come to that, and accountability. COI of IEC means conflict of interest. Any conflict of interest of any ethics committee member at the time of appointment, it shall be declared. There shall be no conflict of interest. And before every meeting, we declare that we have no conflict of interest in relation to the proposals that are before us. And then of the principal investigator. Principal investigator also has to give a declaration that he or she has no conflict of interest as far as the research proposal in submission. Now, ideally for transparency, information shall be put on the website. And of course, clinical trials, clinical trial registration of India, it shall be registered. And record storage shall be appropriate. It should not be accessible. It shall be accessible to only the designated persons, research personnel. And archival is for a long duration of storage and retrieval. There will be a work manual and guidelines accordingly. Institutions follow that. Now, totality of responsibility depends, is vested with all, whether it is a sub-investigator, co-investigator, PI. See, there will be a work manual and the SOP of the ethics committee. Accordingly, everybody is held responsible for a good ethical conduct of research. And that the SOP is approved by the national regulators, that it is DHR or CDSCO or CCACA. They will approve all these work manuals or SOPs. Now, environmental protection, of course, these days, for the last over few decades, now importance is given to protect the environment. Your research, if it is involving any environmental pollutants, they shall be disposed of appropriately, and there shall be no biohazard effect of your research. So this shall be the responsibility of both the PI, IEC, and that of the institution. Now, coming first to clinical research. So now what are the types of clinical research? One is interventional, that is clinical trials. Now here again, clinical trials, there are regulatory and non-regulatory. Regulatory means, in a simple way for our understanding, pharma-sponsored clinical trials. So they are sanctioned or approved by Central Drug Standards Control Organization, CDSCO or DCGI, and that does not come under the purview of today's my presentation and also of the RGHS funding. So RGHS funding, ethics committees, they are covered under the DHR. I will come to that later. So this next is investigator initiated, non-regulatory. So non-regulatory is academic clinical trials. Academic clinical trials are off-label studies. In simple way, dosage and the forum, they are changed. So in those studies, it is academic clinical trial. You can take up academic clinical trial with the DHR registered ethics committee approval for funding by RGHS, but there are other issues. I will come to that subsequently. So there are also investigator initiated interventional studies, that is IIIS, that is like any procedure or any surgeries. So these also are covered under the ethics committee that is registered with DHR. Now, regarding medical devices studies, of course, they also come under the, there are different types of medical devices studies. Some post-marketing studies, they come under the DHR registered ethics committee, but that doesn't come under this present RGHS funding. Now, next is Institutional Ethics Committee. Now, what is the role of the Institutional Ethics Committee? I think now most of all medical colleges, most of the dental colleges, they have their own ethics committees, and other nursing, for pharmacy also you may be having your own ethics committee. You will have your ethics committees. So the responsibility of the ethics committee is to protect the dignity, rights, safety, and well-being of the study participants, ensure that the universal ethical values and international scientific standards, that is the GCP guidelines, they are followed. And ethics committees, in addition to scrutinizing the research proposals and giving approvals, they shall also assist the institution in development and education of a research community that is responsive to the local healthcare requirements. A good number of ethics committees, they do this. They conduct some training programs for the faculty, for the postgraduates, and even for the undergraduates that is being done. Now, this is very important. I think you must focus here. Some of you may not be familiar. So if you are not familiar, you please give attention here. For humans, there are two institutional ethics committees in every institution, means wherever they are. One that is registered with the Central Drug Standards Control Organization, that is the Drugs Controller General of India, DCGI. So that doesn't come here. So please remember that is regulatory trials. University funding is nothing to do with the CDSCO registered ethics committee. So that is regular pharma trials, we can say that. Now, what university funding and university scrutinizing research proposals are covered by the ethics committee that is registered with Department of Health Research, Indian Council of Medical Research, New Delhi. So there are three, if you visit the ethics committee DHR, there are three types of approvals that are given. Not the three types, there are three categories of approvals that are there on the site. We check it. One is a provisional registration that is of 2 years. That is the initial approval and registration of the ethics committee is for 2 years. That is considered as provisional. And once that provisional expires, and then the regular or final certificate is given. So provisional is 2 years, final is 5 years. And if it is not there anywhere in between provisional or final, provisional has expired and nothing has happened in between, it will be found in the list of expired. So please ensure that when you are applying for the ethics committee, for the RGHS funding, your ethics committee is having a provisional registration or a final registration certificate that you can see from the DHR ethics committee website. So you can get it from there. You can talk to your member secretary, and in case of any problem, please contact Dr. Ramchandra Shetty, Director R&D. So this DHR Ethics Committee covers academic studies and also interventional observational studies and interventional studies like academic clinical trials, investigator-initiated studies, and non-interventional observational studies. So, yeah, okay. So now, most importantly, prior IEC approval of the research proposal is mandatory for conducting research studies, presenting papers in the conferences, and publishing papers in peer-reviewed and indexed scientific journals of repute. So please see that anyway, when the application form is released on the website of the RGHS, there will be a provision where you will be asked to submit the ethics committee approval letter. So please see that your ethics committee has a registration that is valid with the Department of Health Research, and either it is a provisional one or a final one. If it is figuring in the list of expired ethics approvals of the ethics committee, then it is a red alert. You have to contact the RGHS. So the references I have given here. So next is after clinical research, now I come to public health research and ethical actions. See, the Department of Community Medicine, Department of Public Health Dentistry, Public Health Nursing, you undertake research in in the community settings or population settings. So what are the types of studies that are normally taken up in the population setting? They are broadly classified into two categories. One is observational studies, another is interventional studies. Okay. Now, what are the observational studies? Observational studies are largely population-based cross-sectional surveys that is going to, like in a simple way, house-to-house survey, one-time contact, and informed consent would suffice. Whether it is a signed informed consent or oral consent, that your ethics committee will give the direction. So your ethics committee guidelines are supreme and binding. So whatever guidelines they give, you follow that, and that will be acceptable in the university. Now, next is the case control studies. Here, informed consent is required if the subjects are in contact with the, or if using records only, then waiver of the informed consent by the institutional ethics committee may be obtained. That will be decided as per the work manual or SOP of your institutional ethics committee. So please follow your IEC guidelines. Now, lastly, the cohort studies. Cohort studies, of course, informed consent of both exposed or affected person and the control group. It is necessary because whenever you come in contact with a person or a patient, please remember informed consent is mandatory. Whether it is oral or signed, that your IEC will give the directions, but you will have to comply with that. If you are coming in contact with only material, if you are coming in contact with only paper, that is record, then you have to approach the ethics committee for a waiver of the regular full board or full committee approval. Now coming to the interventional studies. Now, what are the population level interventional studies? Of course, I just give some examples which are almost historical. Use of iodide salt on a large scale population study, mass vitamin A prophylaxis, iron and folic acid supplementation for pregnant women and in school children, DOT therapy in tuberculosis, mass DEC, heterozyme in filariasis. So anything that is interventional at the population, even the vaccination programs, they are interventional. So they are, of course, they are done in a different way. But any intervention that is done at the population level, IEC approval is mandatory. Now coming to the animal research. Now I will confine myself only to small animal research because that is where the approval is required from the Institutional Animal Ethics Committee. And of course, our R&D director who comes from pharmacy. If there is anything, I come from the medical background. Animal houses were removed from the medical colleges because we were considered not suitable to conduct animal experimentation. So it has gone to other institutions. So that happened during my tenure only as a Dean and director. So anyway, coming back to the animal experimentation, mice, rats, guinea pigs, and rabbits. There is a committee in the Ministry of Animal Husbandry, Government of India, which is the regulatory agency that is known as Committee for Control and Supervision of Experiments on Animals, CCSEA. For any experimentation on small animals, approval of the Institutional Animal Ethics Committee, IAEC, is mandatory. Just like Human Ethics Committee approval is mandatory, prior approval. Similarly, IAEC prior approval is required before conducting the study. Now, IAEC registration with CCSEA is compulsory, is mandatory, just like Human Ethics Committees with DHR. Of course, for online services of registration and all, you can go to this website. Now, coming to the administrative requirements. So this is very, very important. Please listen very carefully. I will take some 10 minutes. For clinical and public health research that involves humans, letter of approval by the Institutional Ethics Committee that is registered with Department of Health Research, Indian Council of Medical Research, Government of India, shall be obtained by the PI on the letterhead of this ethics committee that is duly signed by member secretary. Please note, we will not accept the signature of your principal. It shall be signed by the member secretary, specifying the title of the project, the name, designation, oblique designations of PI or co-PIs, and duration of its approval. See, the project may be of 2 years maximum under the faculty research. So ideally, you take it for the duration of the project. You please request your member secretary and take approval of your project from the ethics committee for the duration of the project. Usually it is 2 years. Take it for 2 years. If it is for a shorter, lesser duration, you take it for the entire duration.
And total number of samples.
So provisional, conditional, and temporary IEC approvals will not be considered. So please remember that provisional, conditional, and temporary IEC approval, because we have come across a lot of problems in this. See, I have been there in this faculty research since 2017, almost 10th year now. This has evolved over a period of time. So provisional, conditional, temporary approvals will be returned back and funding will not be possible. DHR registration certificate of IEC from GOA shall be submitted and the registration of the IEC shall be valid. Not, I told you, no, not date expired at the time of submission of the proposal. We can verify it from the website. Of course, you please submit it from your side. Any doubt, any clarification, contact Department of Advanced RGHS. Now, please, this is something which you must carefully listen, and if you have got any doubt, you can put it in the chat box. I will answer them. If your institution does not have a DHR registered ethics committee, then your institution can utilize the services of another ethics committee that is known as host institution, preferably in the adjoining nearby area. This is ICMR guidelines language. Okay, provided that an MOU is established between the two institutions, that is user institution and host institution. Host institution is that which provides the IEC services, and user institution is the one which does not have the IEC. You utilize the IEC of the host institution. So a user institution, alternatively, as per the ICMR guideline, if MOU is not possible, at least your institution which doesn't have the IEC, you as a user institution, you should provide a no objection certificate to the host institution and agree to be overseen by the host institution, because your research shall be supervised by the ethics committee of the host institution. So for that purpose, you will have to give a NOC if a regular MOU is not possible. And a copy of the MOU between the two institutions or NOC by your institution, that is the user institution, shall be submitted along with the research proposal. Please note it. I have put it bold, underline. The IEC approval letter from CDSCO registered ethics committee will not be accepted, or any later submission. See, sometimes we have come across very funny argument that you please give, university should give approval, then the ethics committee will consider and then will give the approval. No, it is not that way. University is government and it is funding agency. So your ethics committee should give the approval. And if only ethics committee has given the approval, then the university may consider giving approval for your proposal. It is not the other way around. So we have come across all funny things. So please remember that it is DHR registered ethics committee approval only. It shall be registered. Registration is valid and it shall be signed by the member secretary on the letterhead, not by the principal, and it shall be for the duration of the study, and whatever is the sample size or number of subjects, everything shall be specified as per the protocol. Now, in case of academic clinical trials, I told you, academic clinical trials in a simple way, off-label studies or investigator-initiated interventional studies, the PI shall obtain the cost estimate of the study insurance policy from a public sector insurance company, because this is government, like Oriental Insurance, National Insurance, New India Insurance, or any other. And specific to your study proposal, you see, you have to submit the ethics committee approval and also your study proposal copy to the insurance company. And there will be a person and a committee who will examine that, and they will fix up the premium. And that premium certificate has to be enclosed for university to consider giving that from the under the budget if your study is approved. So what is important is this is your study specific clinical trial insurance policy, and this you please include the in your the insurance premium, clinical trial insurance premium in your study budget for funding by RGHS, that is the sponsor. Please note and do not confuse this clinical trial insurance with regular professional indemnity insurance. They are different. Now coming to animal research, IAAC approval letter of the research proposal shall be signed on the IAAC letterhead with the signatures of the chairperson, member secretary, and CCSEA main nominee, not link nominee, and also specifying the period of its validity is compulsory. Provisional, conditional, temporary approvals will not be considered. Anything further, he will add it. The CCSEA registration certificate of IAAC from GOI shall be submitted along with the proposal, and IAAC registration shall be valid at the time of submission of the proposal. Please, just like human registration, animal registration is the same. Now, when it is not involving humans, when it is not involving animals, then it is in vitro research. So in vitro research, the university requirement is a letter on the institutional letterhead stating that the research does not involve either humans or animals and no ethical issues are involved. This letter shall be submitted by the PI along with the application, that is duly signed by the principal, head of the department, PI and co-PI. Please ensure that this letter is submitted along with your proposal. So important note again, I will ensure double emphasize, overemphasize, the submission of the ethics committee approval letter along with the proposal is mandatory for processing the proposal in RGHS. The PIs shall request the ethics committees to consider the proposal under expedited, that is fast tracking. In case the IECs, if there is insufficient time for full committee review and approval for submitting the research proposal before the last date stipulated by the RGHS. Is it clear? So you will have to ensure that along with your application, the IEC approval letter is also submitted. So normally a good number of the studies, because of certain lacunae at the institutional level for institutional ethics committees, so these usually appear to be a roadblock, but it is a legal requirement, so we will not be able to help you out. So with this, I conclude my presentation and thank you for your attention. And now I will look into the chat box. I told in the beginning only, they should put if there are any questions in the chat box. Let me see, where is the chat box? Here. Okay, chat. Okay, there are many. Okay, let me see. I audible, yes, visible. Okay. Anywhere. All names are there for attendance certificate, if I am correct. Okay. Okay, no, I told I'll take only 45 minutes only. So I am here. So you can even I'm checking the chat box. If there are no questions in the chat box, if you can open the mic and you can even ask. Here there is a question. If we have no publication experience, are we still eligible for this research grant? Uh, what is the timeline for submitting the research proposal? You see, the application when it is on the website of the university, it will give the last date and all. So if we have no publication experience, okay, yeah. So tomorrow or day after tomorrow, the notification will be hosted on the website of RGHS, and the last date to submit is 30th of June. So the moment you see, as Professor Anurag Kurpat was telling, you will have to strictly follow the components given in the application form, and you will have to precisely fill it up. See, sometimes there is just designation and institution. Designation is not mentioned. Institution is mentioned. See, you have to read very precisely what is being asked and what you need to answer. See, very casual filling up of the application form I have seen. So that is because I have been scrutinizing the applications from the beginning. So I was very casual. See, what is asked and what should be your answer. If it is not applicable, nil, you please state it, but don't leave it blank. If we have no publication experience, are we still eligible for this research grant? This I find it little. You see, most of you are faculty. So if you have attended this webinar and you get the attendance certificate and you are a regular faculty, not a part-time, temporary, ad hoc, contractual, then you will be eligible, is what I understand. If there is anything, you can contact RGHS separately later. Okay, then let me just check any other question. You can share. Okay, these guidelines my slides can be shared, but most of it, your institutional ethics committee guidelines will have it. I have given the references, ICMR guidelines. These days, Google is there, ICMR 2017 ethical guidelines. You type, you will get the PDF, download it and read it. Okay, if you want my slides, you can ask university and they are easily shareable, freely shareable. What should be the sample size? So you see, another thing is, please remember, please consult a qualified and experienced medical or biostatistician to get a correct sample size to meet your objective. So this will also be scrutinized here. What happens is sometimes uh, certain faculties, they are not familiar with the calculation of the sample size. I'm not going into details that may offend some people. So when it ultimately comes here, so the sample size may be found inadequate or inappropriate. Sampling design is not appropriate. So then the study may fall flat. Please ensure that you consult a qualified and experienced biostatistician and give your sample size calculation formula, and then you give the final calculated sample size and sample design. One more thing I would like to tell everybody, please see that your research proposal as a flow diagram. To repeat, your research proposal as a flow diagram, which was told in the morning by Professor Anurag Kurpat, your research proposal as a flow diagram of your research protocol. So your study design, study methodology is given as a research, as a flow chart. So this will make things easy for the reviewer and for you also for a better clarity of your research proposal. I think I have come to the end of the, there is one question here. Okay, okay. Oh, there is an interesting question. 1 minute, let me. R2, ಸ್ವಲ್ಪ ಇದೆ ಹೆಂಗಿದೆ
ಇಂದು ಮೇಲೆ ಹೋಗು ಸ್ವಲ್ಪ.
Sorry, not teams.
ಟೀ ತರ್ಸಿ ಯಾವ್ದು ಟೀ ತರ್ಸಿ ಮೆಂಬರ್ ಏನಿದೆ ಅನ್ಹ್ಯಾಪಿ ಫಾರ್ ದ ಮೆಂಬರ್ ಸೆಕ್ರೆಟರಿ ಈಸಿ ಇಫ್ ದ ಪಿ ಐ ಇಸ್ ಅನ್ಹ್ಯಾಪಿ ವಿತ್ ದ ಇ ಸಿ ಡಿಸಿಷನ್ಸ್. ಇದು ಸ್ವಲ್ಪ ಇದೆಯಾ ಸ್ವಲ್ಪ ನೋಡಿ ಅದು ಸ್ವಲ್ಪ ಹುಡುಕಿ ಸ್ವಲ್ಪ ಜಂಪ್ ಆಗ್ತಾ ಇದೆ. Interesting question. There is, I have time is there.
Time is at 10.
ಸ್ವಲ್ಪ. What should, sample size I have addressed. Yeah.
So I have not applied for grants. My PhD synopsis was accepted last December. Can I apply for the grants now?
No, take
Okay.
PhD ಮಾಡೋದು apply ಮಾಡಿ.
PhD ಆಗ್ಲೇಬೇಕಾ?
ಅಲ್ಲಲ್ಲ PhD ಇದು simultaneous ಅಲ್ಲಿ ಮಾಡಲ್ಲ.
ಅಲ್ಲ, PhD synopsis accepted. He will, he has completed work. Only thesis submission is left with.
Okay.
I think since the person Vishal BM, since you have already submitted the PhD synopsis and it is accepted, only PhD thesis submission is left with, then you are eligible to apply. If synopsis is not submitted and if still you are working, you are not eligible to apply. I think I have answered your question well.
Next ಅದಕ್ಕೆ ಇಲ್ಲ ನೆಕ್ಸ್ಟ್ ಅನ್ಹ್ಯಾಪಿ ಐತಾ ಇದೆ ಪಿ ಐ ಇದೆ ನೋಡ್ತೀನಿ. ನಾನು ನೋಡ್ತೀನಿ ಯಾವ್ದೋ ಇದಿದೆ ಎಲ್ಲೋ ಒಂದು ಬಂದಿದೆ ಅದು ಜಂಪ್ ಆಗ್ತಾ ಇದೆ. ಇಲ್ಲ ಶುಗರ್ ಇರ್ಲಿ ಪರವಾಗಿಲ್ಲ ಏನ್ ತೊಂದ್ರೆ ತರಿಸ್ಬಿಡಿ ಯಾವ ಸಿಗುತ್ತೆ.
Let us know the criteria for co-PI as it is not mentioned in the RGHS guidelines. Sir, one thing is that co-PI shall be from the same department of the same college. He shall be one of the researcher associated with the project. Okay. I think any professor or assistant professor working in the same department is eligible to become the co-PI.
See, the reason is sometimes the PI leaves the institution for whatever reason. Then the co-PI, who is from the same department, same specialty, obviously, shall take over and continue the project. That is one of the strong reason for having two PIs. One is a PI, another is a co-PI.
Those who are having more, those who are having more than 4 people, do they need, what is the, do they need
to attend in a
do they need
ಅದೇ ಇದಿದ್ರೆ ಸ್ವಲ್ಪ ಮೌಸ್ ಇದ್ರೆ ಮೂವ್ ಮಾಡು. ನಮಗೂ ಅದೇ ಮೌಸ್ ಇಟ್ಕೊಂಡಿವಿ.
who are having more problem, do they need?
ನನಗೂ ಹಂಗೆ ಜಂಪ್ ಆಗುತ್ತೆ.
ನಮಗೆ ಕೊಡ್ತೀವಿ ಇವ್ರಿಗೆ
ನನಗಿರ್ಲಿ ಬಿಡ್ರಿ ಅಷ್ಟೇ. Do they ಅವರು who are having publications or not having publications, if they are eligible or if they are permanent employee of an institution, they are eligible to apply. There is no restriction on number of publications, but he shall be a established researcher. ನಾಲ್ಕು ಪಬ್ಲಿಕೇಶನ್ ಇದು ನಡೀತದ ಅಂತ
ಅದು ನೀವೇನು ಇದೆ
ಅಪ್ಲಿಕೇಶನ್ ಹಾಕ್ಬೋದು. They can apply any number.
Sir, if the co-PI, if the PI co-PI are unhappy with the EC decisions on release of funds by the institution and accounts, and an important is an essential requirement. You see, whether you are happy or unhappy with the EC decision, we require IAC approval for the grant of funds from the university. That's all. Whether you are happy or unhappy is not our headache. You should be in a position to convince the genuinity and validity of your project to the IEC members or IEC committee. And if they are accepting and if they give approval for your project, that is considered, and then only you will be allowed to present your project here.
See, yeah. This is from Dr. Harish Kumar. See, there is another solution to your problem. See, institutional ethics committees are appointed by the head of the institution. That is your dean, director, principal, or whoever it is. So the appellate authority, let me repeat, your appellate authority against the ethics committee is your head of the institution. So if you are unhappy with your ethics committee, please approach the head of the institution and sort it out at the institutional level. That's why it is known as Institutional Ethics Committee. It is constituted as per the guidelines of DHR, ICMR by your institutional head, and that is approved by the DHR.
ಹಾ ತೆಗೆದ್ಬಿಡಿ ಸರ್ ನೋಡಿ ಇದು ಬಾಮಲ್ಲಿ ಸಾರ್ ಸಾರು ಊಟ ಇಲ್ಲ ಹಂಗೆ ಸರಿ.
Study, what are the options for the investigator to complete the study? Is there a timeline and audit provisions for the IEC? You see, for IEC, we cannot give any timeline. And audit provisions is always there for the IEC people to go into the to supervise your research activity. It is mandated in the Act itself. Therefore, IEC is empowered to audit the provisions, audit your research activity. Hello, sir.
You see, the DHR has permitted the ethics committees to do internal monitoring. So it is up to the SOP of your institutional ethics committee to appoint a subcommittee and oversee or monitor or supervise your research.
Is co-PI mandatory? Yes, it is mandatory to have a co-PI for your project before applying to the RGHS.
That too from same department.
And that co-PI shall be from the same department of the same college. That is very important.
ಯಾಕೆ ಅಂತಾನು ಹೇಳಿದೆ, ಪರವಾಗಿಲ್ಲ, ಕೇಳಿಸಿದ್ರು ಪರವಾಗಿಲ್ಲ.
Hello, what ಹೇಳ್ಬೇಕಲ್ಲ sir?
ಹೇಳಿದೆ.
Can the co-PI for other institute? No. First co-PI shall be from from the same institution. Okay, we will not consider co-PI from other institution if there is no co-PI from your institution. You can have so many number of co-PIs, but one must be from your institution. First one must be your institution only.
Now, with your permission, see, I told you, the first co-PI is actually backup PI for the regular PI in case the regular PI leaves the institution for whatsoever reason. The co-PI shall take his or her position and continue the research. So that is the reason. But for reasons of requirement of the study, you can have co-PI from other department, other institution, from the same RGHS affiliated institution. That will be decided here. That he can tell. Yeah.
If we have returned PhD entrance and are awaiting for result, we also apply for faculty. You see, if you are qualified and registered, then you are not eligible. If you are not qualified and if you are not registered, then you are eligible. So it is all again tricky and overlapping question because PhD entrance has written yesterday only it is completed. It takes minimum one month for declaration of the result. Hence, you have to think twice before applying it. Hello, madam. Sir, if leech is being used in a study, should we take clearance from the Animal Ethical Committee? Leech.
ಆಯುರ್ವೇದದವ್ರು ಇರ್ಬೇಕು. Leech.
Leech therapy.
Yes, yes. See, for leech therapy, you please take the approval from the. This is a very tricky question. For the first time I am coming across. Leech is an animal.
animal, but it will be used to treat human diseases.
Yeah.
Therefore, you see, madam, if you want to use leech, for the treatment of the human diseases, animal ethics, it is not only animal ethics committee, we want IEC, that is Institutional Ethical Committee of Human Research, that has to be taken.
Are you from Ayurveda, madam? Raghavi Rajan. We have some time. You can unmute and you can speak also. So you please take definitely approval from the registered Human Ethics Committee and also ideally from the Animal Ethics Committee. ಒಳ್ಳೇದು ಇವೆಲ್ಲ ಆನ್ಸರ್ ಮಾಡೋದು.
If a leech is there,
Same.
I am a permanent working.
ಅದಕ್ಕೆ ನನಗೂ ಮೌಸ್ ಇಟ್ಕೊಂಡು
Pursue PhD in this research grant. No one can pursue PhD or PG research from this grant. And simultaneously, no one can get research grant for people who are pursuing PhD. Because there is a overlapping, you cannot perform research separately for the project. Therefore, simultaneously, you cannot pursue.
ಇದು ಒನ್ ಫ್ಯಾಕಲ್ಟಿ ಮೆಂಬರ್ ಏನೋ ಇದು.
We have written,
Next.
We'll go with the next session.
but I haven't still received the TIN. If you don't have received the TIN number, but if you submit the letter from the principal stating that, so he or she is the permanent employee of the institution, you are eligible for grant.
Yes, we'll wind up time.
ಆಯ್ತು.
Next. Carefully, sir.
ಮುಗೀತು. ಅಲ್ಲ ಇಂಪಾರ್ಟೆಂಟ್ ಇವು ಯಾಕೆಂದ್ರೆ ಎಲ್ಲ ಅಡ್ಮಿನಿಸ್ಟ್ರೇಟಿವ್ ಇವೆ.
Thanks, welcome.
ಏನು ಪರವಾಗಿಲ್ಲ.
So now the session for this particular session is going to an end, and I thank Dr. Sudarshan sir for his elaborate discussion and answering all the questions which have been posed in the chat box. Thank you once again, sir.
Thank you, sir.
Now next session will be by
Next session.
ಅವ್ರು ಬಂದಿದ್ದಾರಾ?
Online.
Online ಇದ್ದಾರಾ? Next session will be by Lancy D'Souza, a biostatistician. She will be talking about the biostatistics, which is basic requirement for the research. And now I welcome Dr. Lancy D'Souza, biostatistician.
Yes.
And JSS Ayurvedic College. JSS University. I request her to begin her presentation here. I request him to present his decision, his presentation here. Sir, Lancy sir, are you there? Sir, Lancy sir, are you there? Lancy sir?
ನಾನು ಕ್ಲೋಸ್ ಮಾಡಿ ನಾನು ಬರ್ಬೇಕಲ್ಲ.
Sir, can you hear me?
Yes. 1 minute, sir. We will permit you to share your things.
Okay.
Can you share your things, sir, now?
Just sir, 1 minute.
Whether sharing is Kirti.
ಇಲ್ಲ ಸರ್ ಕೀರ್ತಿ
Kirti ಒಂದು ಫೋನ್ ಮಾಡಿ ಹೇಳ್ಬಿಟ್ಟು.
ಪರ್ಮಿಷನ್ ಕೊಟ್ಟಿದ್ದೀನಿ ಸರ್, ಪರ್ಮಿಷನ್ ಕೊಟ್ಟಿದ್ದೀನಿ.
Kirti, enable, yes. Sir, you can begin, sir.
Okay, sir. Thank you very much. Good afternoon,
Sir,
everyone.
you make it slideshow, sir. You can make it slideshow. All right, sir. Please go ahead, sir.
Okay, good afternoon, everyone. First of all, let me correct myself as been introduced as a biostatistician. To be frank, I'm a psychologist by all the degrees, whether it is PhD or postdoctoral or any this one. But I've got experience of around 40 years in statistics and research consultancy. So that's one small correction. And I work for University of Mysore at Maharaja's College. So today's talk is on biostatistics in research. So quickly I'll talk basic introductory aspects And somebody rightly talked about sample size calculation. I'm going to talk about that also at the end. So let me begin with the what you call statistics part, where I'm quickly going through these slides. Statistics is not a single process. It's what you call, it has got four, four levels of processing. I think somebody can mute there. I think. Okay. So statistics is not a single step. It has a four process starting from collection, then compilation, analysis, and interpretation of the data. Where in collection, we basically collect the data either through primary or secondary sources. And in the compilation, we compile or we manage our data according to the objectives or hypotheses preferred, whether it's through software or offline what you call calculations or even manual calculations. Then the next part is analysis, is one of the major part which are going to focus today, where what are the types of statistics we can apply in biostatistics. And lastly, the interpreting part of it, which many of the what you call medicos, they'll confuse with the interpretation. We'll think about that also. But when you talk about biostatistics, it's very simple. It's application of statistical methods where you're trying to analyze the data from various fields like biological, medical, and public health studies or scenarios. Let me straight off talk about types of statistics we use in biostatistics. The first one itself is descriptive versus predictive versus inferential statistics. Then parametric versus non-parametric statistics. Univariate versus multivariate statistics. Then lastly, basic versus applied. There are many such classifications, but I'm taken only the major ones. So when you talk about descriptive statistics, there is a descriptive statistics, a whole world of statistics, which I'm going to highlight later, where descriptive statistics basically gives the idea of what you call describing or getting more details about the sample which are being studied. Whereas predictive statistics usually talk about correlation and regression, where we try to have what you call a inference based on a relationship or prediction, because still we say correlation has not reached the level of inferential statistics. And finally, we have got inferential statistics, where we definitely apply few of the tests where you can draw judgment or the conclusions at the end. That's one way of explaining what biostatistics is. Then we have got parametric and non-parametric statistics, where parametric statistics usually we apply for quantitative data and non-parametric for qualitative data. But remember, once in a while we get a confusion with what you call quality and quantity of the data. That will sort it out when it comes to the what you call statistics part. Then univariate versus multivariate, we apply a single variable at a time, it will become a univariate analysis. If we apply several variables, then it becomes multivariate analysis. Then basic versus applied statistics, where in basic statistics we usually go for simple one, and usually we restrict to the minimal statistics. Whereas applied statistics, we go for high levels of or advanced levels of statistics, which can be having utility in the public scenario also, which may lead to policy making also. So there are various of types of statistics we are going to talk. So starting with the first one, what you call descriptive statistics. Under descriptive statistics, we are going to have these are the statistics under descriptive statistics only. That's why I said descriptive statistics is the whole. It itself has several such types of statistics. So starting with the first type of descriptive statistics is the graphical presentations, where it can give a quick glance, which I'll show you later. Then measures of central tendency, where we are going to talk about the what you call how several scores group together and will lead to a single score, which can represent the entire set of scores. We are going to talk about 5 types of measures of central tendencies. We'll come to that whenever it comes: mean, median, mode, geometric mean, and harmonic mean. Then measures of variability, where we call them as heart of statistics, because it's complementary to the measures of central tendency, where we go again. The vertical principle is somewhat against central tendency. In measures of central tendency, we see how all the groups, all the scores group together to give a single score or to arrive at a single score. Whereas in measures of variability, we see how each score is different from that measure of central tendency. Then you got measures of relationship, different kinds of correlations and predictions. Then finally, we have got transformed scores like Sten scores, T scores, and Z scores, because many times we cannot use the raw scores as such. So we go for transformation of scores into some standardized way or to develop some norms. In such cases, we use Sten scores, T scores, and Z scores. So I was talking about the first type of descriptive statistics is the graphical displays, and these are the different types of graphical displays where we talk about bar diagram, column diagram, and histogram. Then frequency polygon and line diagram. Then OGAI, which will be used for specific purposes. I will be showing each one of them in a sample chart. Then pie chart is another one. Scatter diagram, which is used very much in the regression analysis. Then pictograms, area graphs, and other types. So we start with the first one, what you call the bar diagram. A bar diagram could be simple or compound, or it could be stacked one. So in a simple bar diagram, we just see or we just represent one variable at a time, which you can see what you call in the first graph itself. Or it could be a compound diagram where we are going to have more two or more variables presented together. It can be given in a horizontal way also, but if the last graph you see it's a stacked graph. But imagine in a stacked lamp, you can put a lot of what you call data in one of the what you call one simple graph, because there are 45 values are there in the last graph, and these 45 values have been represented, and you can see a clear-cut trend. The lower bottom one is increasing, the mid one is decreasing, and the final one is the upper one is having a lot of inconsistencies. So the idea in any graph is the trends are very clear. So for a layman, it can be very easily understood. So these are the things for a simple bar diagram. Then you have got frequency polygon, or sometimes we refer it as a line diagram, where you can see it's a continuity will be there. So usually we apply a line diagram or a frequency polygon when there is a continuity of the data exists. Again, you have got a simple diagram or simple line diagram or compound diagram, where in simple usually like we apply one variable at a time over a time period, whereas in the other things we can apply different things over the time periods. So this is like what in the current scenario. This what you're seeing. The first line is IPL over by IPL uh, matches, where you can see sometimes you see these kinds of graphs where there will be continuity will be there. Then there is a cumulative percentage graph called as OGAI, where you convert the frequencies into cumulative frequencies, then cumulative frequencies have to be converted into cumulative percentage frequencies, and these percentages are plotted in a what you call x and y graph format, and you can see there is a linear increase. So idea here is when you draw or when you derive an OGAI, you can really calculate any percentile point in the distribution. So that's the idea in OGAI. So you can easily calculate median. You can calculate any percentiles, any quartiles like a Q1, Q2, Q3, Q4, anything you can calculate without even using a formula. Through directly by a graphical representation or through an OGAI, you can calculate either percentiles or quartiles. So that's the basic benefit of it. Then there is a pie chart. So in pie chart, what we do is we represent the data in a what you call a circle, and following the what you call principle of a circle of 360 degrees, where we proportionately divide the angles or the number of degrees into each. So automatically what you call you can find what you call a kind of diagram which is in terms of circle based on the principle of 360 degrees. Now there are varieties. You can have a simple pie, as you've seen in the first one. There could be 3D pie where third dimension is added, or there could be a donut. But remember, usually we don't apply these charts, pie charts for a mean and SD, mean and other things. We usually apply for a discrete data where if there is a frequency or there is a number. So then we'll apply, and uh, when there is a categories are just 4 to 5, then only it's better to apply or use a pie chart. Otherwise it's difficult if you have got more categories. The categories can be represented by various slices, but the problem is difficult to differentiate if there are more number of categories exist. Then there is a scattergram, if you see here, where a single value representing both x and y. Suppose if height and y of an individual would be there, so that can be represented through a scattergram. The advantage of scattergram is once you derive a scattergram, you can derive a simple fit or a straight line, which you are seeing in the graph on the down right side, where you can get a linear vertical increase in the line, or sometimes it could be linear decrease, or there could be straight line. So idea here is it shows a trend, and the beauty of scattergram is you can develop or you can derive a regression equation y is equal to a plus bx. So that's idea even in scattergram, where you are putting a single data point for both x and y values. X and y values being x is independent and y is a dependent variable, and you can see the what you call the trends. So usually through scattergram, I'm repeating again, you can derive a regression equation. Then there are pictograms hardly used in what you call biomedical research, but in other types of researches, what you call one can use pictograms so that easily understand, where it basically we use an icon, okay, or an ideogram, okay. It conveys its meaning through its pictorial resemblance to a physical object. So it is much used in what you call this one, but in population dynamics and or population statistics, this can be very much useful. But I'm going to talk something more about other types of graphs, okay. So one of the type is what you call area graph, special types. Okay, it displays graphically quantitative data, and this has got a complete principle of line chart, which has been presented earlier. Okay, so the area between the axis and if you see the movement of cursor and the line are commonly emphasized with the colors. If you see, there are 4 colors are there for each group B, A, B, C, D, and commonly one compares in area chart to or 2 or more quantities. Now you can definitely say the trend and area. See the bottom one, it keeps increasing. This one both are increasing. Where what you call in group B, you can see there is a decrease and then increase. Again, same thing is happening. But if you see the group D, the trend is slightly different, where the increase is more on some particular points. So that could be a catch point for the interpretation. So area graph has also got its own implication in the research. And another type of graph, which usually these journal people or nowadays the publication part, where they expect a lot of advanced graphs. So they might expect a box plot. So remember, in a box plot, you have so much of what you call details embedded. Now, if you see what you call a detailed what you call box plot, I'm highlighted one. So you can see what you call the top one is called as maximum, the bottom line or the dash is called as minimum, and there's a box which contains 3 aspects. One is the third quartile, the top one, and the this one first quartile from the bottom, and in between you find what you call a median point, and between first and third quartile the distance is called as IQ or interquartile range. So imagine in a single graph you are presenting 1 2 3 4 5 6 what you call statistics, descriptive statistics in a simple graph. And if there are such simple graphs are there, now you can, I'm going back, and again you can compare. For example, this is a box plot for females and this is a box plot for males. So if you see what you call the males and females box plot for a particular variable, now you can see the variability is more among the males, because the minimum and the maximum, you can see the gap is too much compared to the female, this one. And you can see the median is definitely higher for males compared to females. And even the interquartile range, if you see males versus females, it's more for males. So all these details can be derived in one shot if you have got such box plots. And journals expect some kind of these kinds of graphs, so that more details are given in a minimum article space. Then comes KDE or kernel density estimate, or it's called as a KDE plot. Okay. So it shows the probability density function. You see a bar diagram continuous, but there is a curve which goes up, down, and if you see here, Okay, so it is basically what you call, it's a probability density function, or it's called as PDF of the data, how the data behaves. So basically it is being used to visualize the distribution of the data and identify patterns and trends in the data. That is called as KDE, where this gives what you call idea of what you call probability function or probability density function. And all this can be derived through specific softwares. And there are violin plots. Okay, so these violin plots is basically a hybrid plot of box plot and kernel density plot. Earlier we have seen what you call uh, box plot. Later we saw KDF for kernel density plot. Now violin plots are what you call is a hybrid, where you can mix both of them, and one can visualize the data distribution by what you call, it shows what you call summary statistics, along with the summary statistics and the what you call density of each variable. You can see each violin plot is different from each other, so you can identify where the variability is more, where the what you call density is more, so you can get a fair picture. And definitely the journal people would definitely appreciate if you use advanced graphics like this. So that's all about what you call the plots. Then we go to the measures of central tendency. So as I said, measures of central tendency gives the idea of what you call a score which represents the entire set of scores. And suppose you got two such scores, you can compare across the groups. So there are 5 types of measures of central tendencies, starting with the mean, median, mode, geometric mean, and harmonic mean. Remember, mean is used maximum in research. Geometric mean and harmonic mean are used in specific situations, but median is calculated only for what you call to find out the midpoint of what you call the central point of a distribution, which cuts the distribution into two equal halves, so that you can make low and high groups. And mode is what you call value which occurs most number of the times, but mode is very what you call rarely used, or many times I can say mode is not at all used. If I see few of the what you call journal articles and all, so I don't find what you call model values, but usually we find mean and median. And as I am repeating, geometric mean and harmonic mean are used based on the what you call conditions required, or specific under specific conditions. Then measures of variability. Okay, so basically the measures of variability also goes by different names: measures of spread, measures of dispersion. All those things are named for the same, but basically it shows how much is the data is homogeneous or heterogeneous. It's basically spread of a group of scores. So the idea here is a variation. Okay, please remember, when we say variation, variation is the heart of statistics. If there is no variation, there is no need to the statistical analysis. The mean itself will give the answer. So that's why variation is required. And remember, when we say heterogeneity or homogeneity of data has a lot of impact on your final outcome in the data analysis. If your data is more heterogeneous, you're bound to lose the significance of the results. Your p-value may be non-significant. If the data is homogeneous, there is a likelihood that you might get a better results than the data when it is heterogeneous. So be careful about data. Whenever you collect the data, be careful about the data collection part, because the heterogeneity comes because of at least for the 3 reasons. One is for the wrong sample, another one is the wrong tool, third one could be the wrong input or output from the computer or machine which are used for analysis, especially what you call in the biochemical analysis, not statistical analysis. So sometimes we feed the what you call we subject the blood or other materials to analyze to what you call analyzer, and that all those what you call outputs or the results come through a computerized screen. And sometimes if there's a problem with the analyzer or synthesizer, and you can get a value which is beyond unexpected values. So sometimes there could be a problem in the machine itself, or sometimes there could be a problem in the sample selected, sometimes there could be a problem in the tool employed for the specific sample. So all that time you are going to get more variation, or heterogeneity of the data. So you have to be careful while article giving a test or collection of data. Please remember that sample is homogeneous. That's the first thing. And the tool which you are using is definitely applicable for that age specific criteria or even some other inclusion criteria to involve those samples. As I already said, the machinery issues could be tertiary one. So these are the different kinds of what you call methods which people or researchers use in biostatistics, starting with the range. That's nothing but high to low, or the difference between highest to the lowest. Then quartile deviation, not used much, but just to find out the dispersion between Q1, Q2, interquartile range. If you divide by 2, you get what you call Q or QD, quartile deviation. Then mean deviation hardly used in research, but is one of the measures of variability. Then comes standard deviation, the measure of variability. Why you call the measure of variability? Because if you see any of the articles or any of the in presentations, if you see what you call the data or the annals are presented some value plus or minus dash, and this after plus or minus it's mean plus or minus SD or SE. So standard deviation is the measure of variability because it considers each deviation from the central tendency. That's why it's called a standard deviation. So mostly all the article research includes mean and SD if the data is quantitative. Then standard deviation square becomes variance. Then sometimes researchers apply or use standard error to what you call explain the variability. So standard error is the derived form of standard deviation. When you divide SD by square root of n, you get standard error. So usually we say standard error, it can be applicable at the population level, though they say. Then there's a covariance. In few of the researchers, they use covariance where it's basically 100 sigma by n. So depending upon the necessity, people can use one of these measures of variability. And based on all that, now ultimately, why should we use what you call statistics, especially inferential statistics or predictive statistics? Basically to test the hypothesis. So usually in research, we find three types of null hypothesis, alternate hypothesis and directional hypothesis. In null hypothesis, we say no difference, no relationship. In alternate hypothesis, we say there is a difference, there is a relationship. Whereas in direction hypothesis, our directionality is very clear, whether there is a relationship, what kind of relationship exists. If it's a relationship, whether it's a positive relationship, negative relationship, we are going to make it very specific. Or if it's a difference, we are going to say which group is more than other group or which group is lesser than the other group. So we are going to have very specified what you call a way of formulating the hypothesis in direction hypothesis, because here we maintain the directionality. Plus, please remember, whenever you use null hypothesis and alternate hypothesis, we use what you call significance level at 95% level or 0.05 level, 95% confidence. Whereas in direction hypothesis, we reduce it to 0.025 level, automatically becomes one tail test, or we say 97.5% of confidence. So all these hypotheses are used in statistics. But I want to tell you something very important. Whenever talk about null hypothesis in research, they usually say whenever you formulate a null hypothesis, it's meant for rejection. It's meant for rejection. And whenever you formulate alternative or directional hypothesis, it's meant for acceptance. By not doing so, then we are committing two types of technical errors called as type 1 and type 2 errors, which we'll be discussing further. Now, after having all that, we come to the data part. So usually we talk about two types of data in research. One is on a simple level, it's called as categorical data and the numerical data. So when you talk about a category which is not being quantified, so if you go for measures of what you call levels of measurement, in statistics we have got 4 levels of measurement, starting with the nominal, ordinal, interval and ratio scales. So the first two levels, nominal and ordinal levels, usually we derive data in a categorical form. Whereas in the next two levels, that is intro scale and ratio scales, we get a data which is in the numerical form because they're called as advanced scales of measurement, whereas nominal and ordinal scales are referred as primitive scales of measurement because there is less of quantification, where the last two scales, that is ratio and intro scales, there is more of specific quantification arises. So categorical data can be later can be termed as qualitative data because we usually explain quality of a variable through category, and we refer later it as non-parametric data. And for non-parametric data, we have a set of statistics called as non-parametric statistics like chi-square, Wilcoxon sign rank test, Mann-Whitney test, all that. Likewise, for numerical data, since it's quantitative in nature, so we refer it as a quantitative data. So quantitative data, we refer it as parametric data. So once you say parametric data, immediately you should remember t-test, f-test, product moment correlation, all that will come under parametric statistics. So ultimately now we are switching over to non-parametric statistics and parametric statistics. But how the data would be in parametric? See, the data would look like in parametric some numbers, and you can calculate the descriptive statistics, all of these. So that's why it's called as parametric. Why parametric? Because you can derive several parameters from a set of data. For example, you have got a data set of 15, 12, 16, 18, 20, 25, and 10. Now you can calculate all these what you call descriptive statistics which are shown in the what you call screen, where everything is possible. So you have got a few sets of data, and at least 13 types of what you call statistical measures through description we can measure, which is not possible in non-parametric data. So for example, if I say in a group of study there are 25 males and 35 females, please remember this is not a quantitative data, this is a qualitative data, because you have got a number of people as 60. 25 by itself is not a true number, it is just frequency of occurrence. Many times we get what you call we get wrong statistics done because of this, because we think male 25 and female 35 as qualitative quantitative data than quantitative data. So for this we can calculate only percentage or frequency, but you're back to numbers. So that's the idea, where in vertical sometimes or whatever the data you have to ultimately reduce it to frequency and percentages, which cannot be converted into quantity. It is just frequency of occurrence. And many times people have miserably failed applying parametric statistics over non-parametric data. So be careful. So whenever you apply what you call a particular statistics, there are more conditions apply. When it comes, I'll let you know. Then whenever you get a data, whether it's parametric or non-parametric, you have to test the data through statistics. And such data usually will be either predictive statistics or inferential statistics. Now, when you come to the steps in hypothesis testing, you should have a problem definition or what you want to do. You can state null and alternate hypothesis. This is a traditional way of presenting. I don't know, you can go by the university protocol or the what you call guidelines which has been given, how you are going to do that. So you have to state the null hypothesis, alternate hypothesis, or even direction hypothesis, because these are the things are must. Then once you have got null hypothesis and alternate hypothesis or direction, any one of them, now you collect the data. Once you have what you call the data with you, now you have to think of choosing a relevant statistical test based on the hypothesis or even the objectives or sometimes even research questions, and you have to find out an appropriate what you call probability distribution. Then you have to choose a test. Okay, you are chosen a test now. Now you what you call after the test results come, you have to determine its significance level at 0.05 level or at 0.01 level or at 0.001 level, along with the idea of degrees of freedom. Because remember earlier it used to be like we used to have a textbook, you calculate the value manually, and then you calculate degrees of freedom based on n minus 1 or n minus 2 or sometimes c minus 1 into c minus 2 or r minus 1. So whatever the what you call df formula used to be there for a specific test. So that time what you call degrees of freedom is required to refer the critical value or the standard value which has been given in the textbook. Nowadays, through software, you get automatic. So you have to determine the significance level at 0.501 or at 0.001 level. And along with that, you have to decide whether it's one-tailed or two-tailed test. As I said, usually direction hypothesis, they will be under one-tailed test, whereas alternate and direction hypothesis, usually they come under two-tailed test. Then you have your test value. You have tested for some difference or some relationship. You have got a value with you, and this value has to be what you call compared with the critical value which has been given what you call in the textbook or auto. Then if your test statistics, calculated statistics, is equal or more than the table value, then you say it is significant, usually except man-Whitney test. And if your value calculated is less than the table value, then you say non-significant. So depending upon the significant or non-significant, now you have to see what you call, if you have formulated a null hypothesis and if your values are significant, then you reject the null hypothesis. You have formulated a null hypothesis, your results are also non-significant. That means your test statistics not falling in the critical region, then you are not going to reject the null hypothesis. You are going to accept the null hypothesis. The same way holds good for alternative and direction hypothesis. So how you go for it? Now, based on this backdrop, we are going further. 4 types of statistical groupings we are going to check under 2 major headings, parametric and non-parametric. So under parametric, we are going to check 2 types, difference based and relationship based. And in non-parametric also, we are going to have difference based test and relationship based test. So we are going to have 4 types of statistical methods under 2 major headings called as parametric and non-parametric. But before that, please consider before getting into the any kind of statistical analysis, I would expect you to what you call consider the following important aspects. Otherwise, uh, again I'm telling, if you don't use the relevant statistics, then there could be what you call non-acceptance more by the journals. There could be rejection rates more. You should apply appropriate statistics. You should interpret accordingly. All those things stands. Okay, first you think of whether data is categorical or numerical. If it is categorical data, invariably you have to go for a non-parametric test. If it is numerical test, you can go for parametric test, but subject to the condition which will be discussed soon. And what is required in your what you call objectives or research questions or hypothesis? Are you going for a difference test or are you going to find out the relationship? So don't do difference in the place of relationship, and don't do relationship in the case of difference, because remember, the software gives any kind of tables accordingly how you specify. So because you cannot blame the software, because uh, except AI, software takes care of what you call what you have given the instruction to the software. And then you decide what kind of statistics you are opting for, parametric or non-parametric. I will give the nature of parametric or non-parametric statistics. Then ultimately, statistics when you conduct, are you going for a manual calculation which is what you call quite strenuous and time taking, or are you using a software like nowadays you got Jamovi or SPSS or R Studio or JASP JSP? So we have got several softwares one can use, but some are license bound, some are free on the what you call net. Or are you going to outsource it? Like there could be people working over it. You have to give your data, and uh, the people will get you ready tables. You can submit. But my simple idea is nothing wrong in outsourcing, but you should be knowing what is the principle behind each test which you have presented as a tables in your results or where the section comes. So because if you don't know the principles of a test, then very difficult to give a what you call explanation in the viva. So that's why either if you do by yourself, it's very good. If you outsource, you should be knowing the background of the test or the need of that test and requirements of a test and its applications. I was telling about what you call you can apply for what you call for qualitative data. You can apply categorical measures or this one, where usually we end up with the non-parametric statistics. But if your data is numerical, please remember, before you start what you call any numerical data analysis, I would expect you to go for a normality check. A normality check of the data, which is very much required. Why? Because
Sir, your slide is not displayed.
so not coming.
Nancy, your slide is not displayed. Once again, you share.
Okay, sir. Okay, sir.
I think last two slides are there.
So now it's being displayed.
Ah, yes. Make a slideshow, sir. Stopped again.
Sir, if I go for slideshow, it will be stopping, sir. That's the problem.
And then you just go ahead with the need not be slideshow.
Sir, now you are seeing it.
No, now it's not seen. Please, you go ahead with your talk. Don't make it slideshow. Simply you display your slide.
Okay, okay, sir. Okay, sir. Sir, now you are seeing.
No. Now we are seeing, sir.
Okay, okay.
Kernel density. Okay.
That's all over, sir. I was here, sir. Okay.
Ah.
Okay. Sometimes your data is quantitative, and we talk about the parametric data. Plus, but as I said, if you don't go for a normality check, there's a what you call high probability that your article may not be accepted. So usually they go for what you call one of the tests called as normality check of the data. Have you checked your data for normality? Why? Because if there are too many outliers are there in a data, you might get a different result, and the general people expect a very serious thing here, where they expect check your data for normality, where if it has got more skewness or kurtosis, that means though your data is parametric, you are not supposed to apply a parametric test. You have to go for alternative non-parametric tests. So that's the idea, to check the normality. And how to check this normality? You have got to, what to call at least in most of the softwares you find these two. There's a Shapirovic test and Kolmogorov-Smirnov test. So the Shapirovic test usually we apply when n is less than 50, and Kolmogorov-Smirnov test where n is more than 50. Now, please remember how to identify this, whether your data is normal or non-normal or not following the assumptions of normality is based on the test value. Your Shapiro-Wilk test value or Kolmogorov-Smirnov test value should not be significant. If it is significant, means your data is not following normality. So if your data is not following normality, then you cannot apply regular parametric tests. You have to go for alternative non-parametric tests. So please keep a note on this, whether it's your project reports or whether it's your publication or whether it could be thesis reports. All these things nowadays are what you call seen very seriously about the statistical application and the normality check. Now, having all that in our vertical mind, we start with the parametric test of difference based. So we start with the difference based test for two groups. So whenever we talk about difference between two groups, usually we talk about t-tests. So there are usually three types of t-tests are available. One is independent samples, paired samples, and one sample t-test. And I have given another name called as z-test. Now remember, independent sample test, I'll come to the details very next. Independent sample test is used when you want to compare the mean difference between two groups which are drawn independently from the population. But remember, this comes with a rider. That rider is nothing but your sample size should be less than 30. If your sample size is more than 30, then you have to go for a Z test. So this is just a correction. Independent sample test or Z test, both are comparing a mean difference between two groups. Mean not the two variables, mean difference between the two groups. And if your sample size is more than 30, please go for Z test instead of independent sample t-test. So what's paired samples and one sample test? We'll proceed now. See, independent sample t-test, as I said, you check two groups article which are very different from each other, and your sample size is less than 30. And usually what we do in independent samples t-test is we see the mean difference between the two groups, and we see whether this mean difference is significant or not. So that's the idea in independent sample t-test. It goes by other names also. For example, in your textbook still you can find student t-test. Sometimes it's called as two samples t-test. Sometimes it's called as unpaired samples t-test. But please remember, all these names are same for a single test, but the latest nomenclature is independent samples t-test. So that's the idea in independent samples t-test. And the next one is paired samples t-test. A same sample is exposed twice. You have pre-test and post-test. So in such cases, you can go for what you call paired samples t-test. And remember, in the previous case which I showed you, independent samples t-test, n may be same or n may be different in two groups. But when you come to the paired samples t-test, what you call the n must be same, because the same sample, because there's a one-to-one correspondence between what you call each subject in a group, and there's a matched pair. Suppose you are suppose if it's Ayurvedic research, and if you are using a single drug Brahmi, so effect of Brahmi, because Brahmi acts as a brain tonic. So if what you call Brahmi is being used, now remember, you test the group before what you call administration of Brahmi and give it for 3 months, and again test later for a particular variable. You can apply. So it could be application before therapy to after therapy, or before therapy to follow up, or even after therapy to follow up. So at a time you use what you call two two sessions or two time points for the same what you call sample. That's what's called as paired samples. Then you have got one sample t-test where you check your group mean against a standard mean, and the standard mean is usually derived. The standard mean is usually derived from a population standard, where I have given what you call how the population standard is being employed, whether it's SBP or DB by 120 by 80, or if it's SpO2 9500. Because in most of the medical parameters, the standards have been established, and you need not have a what you call a comparative group or a control group to measure, because with a one sample t-test, you can check your group mean whether it's with the standard or below the standard or above the standard. So that's advantage of one sample t-test, where you don't require a comparable group. Then comes what you call more than two groups, where we are going to talk about ANOVA, or simply analysis of variance. So we have got several variants in ANOVA. So we'll check by one. So ANOVA, in that one way, is there univariate, multivariate, repeated measure ANOVA, as well as ANCOVA. So we start with the ANOVA. As I said, one way, two way, or three way ANOVA. So I give an example like effect of SES on BMI. So because you've got three levels, SES, low, medium, high, or sometimes if you use Kupusamy scale, there could be 5 levels. So effect of SES on BMI. So more than two groups comparison, you come with the what you call ANOVA, and ANOVA is basically considered as extension of t-test. Whereas in two ANOVA, we employ two independent variables versus one dependent variable. Along with the SES, now I'll add age. So age and SES on BMI. And in three-way ANOVA, I go furthermore, where I employ three independent variables but against a single dependent variable. And if you see whether it's one way, two way, or three way, you find BMI as all the time dependent variables. In one way ANOVA, BMI is dependent, but only one independent variable split into 3 levels or 5 levels, called as SES. Whereas in two ANOVA, BMI remains same. Now I add age and SES two way. In three way ANOVA, I add age, SES, and diet on BMI. Since BMI is all the time considered as single dependent variable, all this comes under univariate ANOVA. So how it comes? So if you see, you or suppose you are using three groups, drug 1, drug 2, and drug 3. So they are different samples. So these three different samples, where can be compared across. So that's the idea there. Or if it's what you call 4 drugs, still one ANOVA works good. And please remember, whenever, sir, somebody's talking, please can you mute? Okay, now, please remember, along with ANOVA, we talk another concept called as post-hoc test. If F-test acts as what you call, if F-test acts as macro level of analysis, post-hoc test acts as micro level of analysis. Because if you apply ANOVA, the value which you derive is F value. Please remember, the F value gives the difference between the three groups or more, but it will not tell which group is different from the other. To go for a micro level of analysis, we have to use a post-hoc test. So usually LSD or least significant difference, or DMRT or Duncan's multiple range test, Sheffy's, Tukey's, Bonfer and Dunnett's. Depending upon the nature of the data, you can apply one of them. But my sincere advice is, by applying LSD or DMRT, the journal may not accept. Few of the journals may not accept this because they are called as relatively loose tests, because even for a small mean difference, it might give a significance. But usually journals expect Tukey's, Sheffy's, Bonferroni or Dunnett's tests, to substantiate your findings or to make it more strengthening. So that's the idea behind what you call post-hoc tests. So two ANOVA already said, two independent variables, I've already explained. Then comes repeated measure ANOVA, where the repeated measure ANOVA is the extension of paired sample t-test. And remember, in paired sample t-test, we just compared pre versus post, or pre versus follow-up, or follow-up 1 versus follow-up 2. But in repeated measure ANOVA, we are going to check simultaneously 3 sessions or more than 3 sessions effect at a time. So, but the idea here is all the subjects are same in all the sessions. So that's why I said it's the extension of t-test. For example, pre-test to post-test, 3 months you have got gap. Then after post-test, you want to see its effect again 3 months. So, but sample remains the same, and you can see what you call the changes over the time, and that changes which, whether it's happening or if at all it's happening, you are going to check whether it is significant or not. That's why we use repeated measure ANOVA. So all this will come under difference based test. Then we have got relationship based test, parametric. Because I said 4 groups: parametric relationship, parametric difference, non-parametric relationship, and non-parametric difference. So we are in the second set now, parametric relationship based test. Invariably we use correlation in a relationship, or sometimes partial correlation and regression. So now the idea here is, when we talk about what you call correlation, we see the mutuality or the dependence of one variable over the other variable. So how it looks like? So the correlations measure the extent of mutuality between 2 or more variables, and the directions of the results are very clear. If x is increasing, y also increases, then you end up with a positive relationship. If x is increasing and y is decreasing, then you have what you call a negative relationship. And if x and y are not what you call having match 1 to 1, or there is no correspondence or dependency of one variable over the other variable, then we say there is no correlation. So correlation could be either positive or negative or no correlation. And the test usually we employ is under parametric side is the Pearson's product moment correlation. So that's a test usually we apply. So these are the what you call examples. And sometimes I mentioned about partial correlation. Please remember, in partial correlation, it's slightly different from the regular correlation, where we see what you call influence of third variable over the existing relationship. So the influence of the other variable, usually we refer it as confounding variable or extraneous variable or intervening variable. To block their effects, we use a partial correlation, or uh, the idea here is you are going to check the influence of this confounding or extraneous or intervening variables over the existing relationship between two variables. Then to parcel out that unwanted variables influence, you can use a partial correlation. The third set we are going to talk about is a non-parametric difference-based test. So usually we talk about chi-square test, Mann-Whitney U test, Wilcoxon-side rank test, and Kruskal-Wallis one-way ANOVA. So in chi-square test, we have got two types. That is, one is chi-square test of goodness of fit, where we are going to have a set of variables, frequencies of variables. Basically, it's a frequency difference. So we check the difference between two groups of frequencies or more. Then it will be simple chi-square test of goodness of fit. Or there should be chi-square test of independence, where in chi-square test of independence, what we do is, if there are cross tabulations, we measure the association between rows and variables for a cross tabulation. That's the chi-square test of independence. And I've shown the variable or another test called as Mann-Whitney U test, which is exactly equivalent to the independent sample t-test of parametric test. If your data doesn't follow normality in a quantitative form, then you can use Mann-Whitney U test rather than what you call independent sample t-test. There I talked about paired sample t-test. The same counter test here is Wilcoxon sign rank test. One way over there and Kruskal-Wallis one way over here. But please remember here few of the intricacies here. Whenever we talk about non-parametric difference-based tests or the relationships, the data, original data will not be considered in the analysis. The data, whatever is there in a quantified form, will be converted into ranks or signs. And later, in analysis, instead of what you call, instead of the using the original scores, the ranks or the signs will be used for further analysis. So in a way, we do a reduction of what you call the weightage of data by convert them into ranks or signs. So that's there in all the cases, whether it's Mann-Whitney U test, Wilcoxon sign rank test, or Kruskal-Wallis one-way ANOVA. And the last test is relationship based test, non-parametric, where we are going to talk about what you call few tests where Spearman's rank difference correlation. So in parametric side, we used Pearson's product moment correlation, where we used original scores, whereas in Spearman's rank correlation, we use basically ranks. For the original scores, we assign the ranks and we do further analysis. That's what's called as rank difference. Sometimes we use contingency coefficient test when the number of rows and number of columns are equal. If it is 2 by 2 or 3 by 3 or 4 by 4 rows by columns, so then usually we go for contingency coefficient test rather than a chi-square test. And sometimes we apply Cramer's V for finding out the association between rows and columns. And sometimes there will be regressions which are called as mixed form. So they are referred as binomial and multinomial logistic regressions. And how do they look like? So in multiple regression, we see the influence of several independent variables over a selected dependent variable. I have given an example of academic achievement of an individual or a student. How the academic achievement of a student being determined by several factors. So starting the heredity, classroom environment, Android usage, exam anxiety, study hours, parental support, motivation, peer pressure, etc., etc. I regress all these what you call scores on a single dependent variable called as academic achievement. Then it becomes a multiple regression where only few of the factors will come as a basic predictors or major predictors of academic achievement. Could be heredity, could be extent of Android usage, could be number of class hours used, but all of them will not come into. So these kind of analysis usually get into the advanced level or multivariate level of testings where one can form what you call uh, policy making. Maybe if you are seeing recently Karnataka government is deciding to ban social media for children or individuals below 16 years. Maybe one of the researchers said usage of more social media has influence on academic achievement or other things. Maybe that could be one of the reason where people are government is trying to put a ban over it, and already few countries have put a ban already. Then sometimes we use the logistic regressions, where in logistic regression we have what you call the data, what you get, your major dependent data will be in categories like happy and sad. And there are several factors, could be numerical or categorical. We regress over it. So suppose what makes VTU or RGHS happy about it, and what makes RGS sad. One can derive several factors and you can regress. Then they can see what makes the individual happy with working with the RGHS or what makes sad. Now, based on this, what you call, one can derive uh, other policy or other, they can change the principles. So that's the idea in logistic regression. Then significance level, definitely I need to speak. We check our data at 3 levels of significance, usually 0.05, 0.01 and 0.001. Accordingly, they are referred as 95% confidence, 99% confidence and 99.9% level of confidence. So if your data is just significant at 0.05 level, we just use the word significant. If it's at 0.01 or 99%, we refer it as highly significant. And if it is 0.001, that means we refer it as very highly significant. Now remember, what is the significance? On a simple level, a 0.05 level of significance gives the idea that if you repeat the experiment or the data collection 100 times, 95 times you are bound to get the same results, 5 times you can miss. The same analogy holds good better. Remember, statistical pass criteria is very high because it's 95 out of 100, whereas your regular examination pass could be just 50%. But in statistical pass criteria, that's a significance level is 95 minimum out of 100. So that's a 95% confidence which you talk about it. Then verification of the hypothesis. Please remember, whenever you start with the checking of in what you call statistics, a null or alternative hypothesis or direction hypothesis we formulate, and your results could be what you call significant or non-significant. Please remember, if you have formulated a null hypothesis and your results are significant, you can reject the null hypothesis. You have formulated alternative hypothesis or direction hypothesis and your results are significant, you are accepting it. This is what we call in a what you call approval mode, because null hypotheses are meant for rejection and alternative and direction hypotheses are meant for acceptance. By not doing so, null hypothesis you accept, that means you are committing a technical error. Alternative and direction hypothesis you are rejecting, you are committing a technical error called as type 1 and type 2 errors. I'll discuss now. Now, I have given a comprehensive table of choosing statistical procedures. If you see, now this gives a complete idea of what kind of data you have and what kind of what you call statistics you can employ. If you want later, I can pass on this the full PPT later, so that also you can think of. Then I was talking about type 1 and type 2 errors, where the technical errors, because this you should not be committed in the research. Because why our articles are not published in Scopus Index or Web of Science or PubMed journals, because we commit a lot of type 1 and type 2 errors, which the reviewers or editors can find out easily and they can highlight. So that's why sometimes this is also one of the reasons. So type 1 error is what happens when the tested hypothesis is falsely rejected. So usually we say a type 1 error is a false positive. I'll give the example later. It's when you say found something, but that something is really an error. The opposite is type 2 error, is what happens when a false test hypothesis is not rejected. It is when you don't find something that is in fact there. Or type 2 error is a false negative. So what are those examples if you want to see? So type 1 error we refer as false alarm or bogus effect, when you reject the null hypothesis when it's really true. And sometimes type 2 error comes miss a real effect, fail to reject a null hypothesis when it's really false. And type 3 error usually comes from the researcher side, lazy, incompetent, willful ignorance of the truth. You should know about it. So I can give an example of type 1 error. A test that shows a patient to have a disease and in fact the patient does not have the disease. Something is not there. What you call, you are giving the idea that it is there. Another example could be a fire alarm going on indicating fire when in fact it is not there. Or experiment indicating that a medical treatment should cure a disease when in fact it does not. So all these are examples of type 1 errors. Examples of type 2 errors is like we talked about the what you call blood test and all. A blood test failing to detect the disease, it was designated detect in a patient who really has the disease. So it's a type 2 error because blood test, the person has the disease, but the test fails to do that. That's the example for type 2 error. Usually whenever a fire breaks out, there should be alarm, but fire alarm doesn't ring, then it could be a type 2 error. So examples. A clinical trial of a medical treatment failing to show that treatment works when really it does. So that also could be a what you call a type 2 error example. And last part, and then I am asking the organizer, can I take another 2-3 minutes?
Sir, you can go ahead.
Okay, another 2-3 minutes, sir. I'll just highlight because you talked about.
Okay, sir, you can go ahead. You can go
Yeah,
ahead.
you talked about the sample size in the previous session, so I just want to conclude with that. So please remember, as sir said in the previous session, you have to really careful about what you call calculation of sample size. It depends upon the type of study. Please understand. So if it's a survey study and all, you can directly use Krejci and Morgan book, where it depends upon, for a finite population, you have got a standard what you call way of calculation is given. So if you see on the left side of that what you call each column, you find the n, and the very next column is s. Please remember, even if you are in finite population 10 lakhs, you require just 384. But as the sample size decreases, you require more and more sample for reliability of the results. So this is one of the, for what you call a survey research and all. I'm just giving you. For a comparative study, you can use this formula: z of alpha plus z of beta square into sigma square by d square, where I have given an example. Z of alpha and z of beta are the standards, where when you talk about z of alpha, the probability of false 0.05 level is 1.96. I have shown down in the analysis. And for 80% power, the probability of failing to reject a null hypothesis for 80% is 0.84. This can be increased to 90% power also, but on a minimal level. Standard deviation, we usually, to find out from a previous similar article with the specific variable, that variable SD, we have to bring it. Then the size of the effect that is clinically worthwhile to detect. Now we have to go for a mean comparison of the previous studies and see what kind of difference it has and whether it's led to the difference or not. But here not bother much about the statistical significance, it's more of clinical significance. So if you simplify that using this formula, you get per group how much to be used, because it all depends upon the SD and the D value. That's where you have to be careful for a comparative study. Then for observational or cross-sectional study, sometimes we use z square PQ by D square. I'm just giving few one. Okay, it depends upon the prevalence. If you have a, what you call a prevalence 12.5%, then you can directly use z square PQ by D square, where z value is 1.96. P is the proportion of prevalence, 12.5% becomes to 0.125. Q is 1 minus P, or what you call 1 minus 0.125, it becomes 0.875. Margin of error, okay, it can be 5 to 10%. So if I use 6% of margin of error, and if you simplify, you can end up with 117 or 120 in total for a study. So this is where I'm going to stop here. So if there are any questions in the chat box, or if somebody can ask openly, please feel free to ask.
Are there any questions on the topic? You see, in this statistical sample size variation as a director, when the presentations were there are two types of, as he has mentioned, one is on the basis of prevalence, another is on the basis of comparison between the outcomes. People, they have to judiciously think which type of sample calculation shall be done. Are they comparing outcome or are they comparing prevalence? In that case, because many people, they go directly easier way, that is prevalence. That is again not mismatching. Therefore, please consider and consult a qualified and experienced biostatistician for calculating the sample. If there are any questions, you can go ahead. Otherwise, sir, are there any questions? No questions.
Okay, sir. Okay, sir. There are. Okay. Kindly do mention. Okay, no, sir. I'll read out, sir, one by one.
Sir, we can test the normality for categorical data, and
Sir,
then how can we say categorical data is following non-parametric from without testing normality test?
Sir, this is a very simple question. For non-parametric data, there is no normality test. One can directly go for testing. It's only for parametric data. It's only for parametric data. One has to go for a normality check. Why? Because non-parametric tests are distribution-free tests. So there is no normality check for non-parametric data or qualitative data. Please keep in mind. And there's another question in the chat box. Kindly do mention once again the book mentioned for sample size. There are several books are available, and you can go to research methodology books and you can check. Okay, kindly send your contact number and email ID, sir. Okay, my email ID is already reflected in the screen. You can check it. Then please share the materials. Definitely, I'm going to give the material. Somebody has given a nice comment, but when it comes to calculations, statistics becomes difficult. So my simple advice is, what you call, change your attitude towards statistics. Statistics is not tough. Our attitude towards statistics is tough. I understand mathematics is tough, but not statistics.
Sir, there is one more question. Explain the clinical significance and statistical significance.
Sir, whenever we talk about statistical significance, sir, are you
Please.
hello?
Please go ahead, sir.
So whenever we talk about statistical significance, we talk about, we use what you call, we use a test. It could be parametric or non-parametric, and we go further. We use 0.05 level or 0.01 level or 0.001 level. But in a clinical significance, it's a practical way or it's a real world importance of a medical treatment or research finding. So here the idea is whether an intervention makes a meaningful difference in a patient life. Statistics is not important, because we cannot say this much percent improved and that is significant. No, here what you call, we are going to determine if a study's outcome is useful or not. We are not going to use any statistics. Okay, so the idea here is we are going to check the what you call meaningful impact of a treatment, or it could be patient outcome assessment. That is more important in the clinical significance.
Sir, one more question is there. Sample size calculation method without any previous data for new drug development.
Sir, they have to do a pilot study first and get the data, then they can come with that.
Okay.
So they have to do a pilot first. So free software, okay, which we can help us to learn. Okay, you can use Jamovi, Jamovi, Jamovi. R and R Studio are little tough, but if you know the C language, then it's easier. But easier one is Jamovi, Jamovi, or JASP, JASP. And another thing I would like to tell you is what you call, where you can use a lot of YouTube videos and you can simultaneously what you call work, or you can attend uh, research methodology workshop, especially statistical methodology workshops, where definitely you can get a what you call maximum input. Sample calculation method without any previous. Okay, that is done. Kindly mention few important apps which will be helpful. Data is already what you call data analysis exclusively in Ayurveda. Yes, that's also done. Pilot study in sample size. Yes, because you require, if you don't have any previous backup, I would expect you to do a pilot study, get that data, and from that data you derive statistics, and that statistics can be used for data sample size calculation. I think those are the
What should be the minimum sample size for pilot study?
Sir, usually, sir, there is nothing like minimum, depending upon the severity and the expenditure involved. But in general, we say to compare any two groups, we require minimum of a 30 sample size to apply test. Minimum of 30 is better.
Next question is sample size estimation for psychometric studies. Any reference is there?
Sir, whether sample size was psychometric or medical or biomedical, sample size, this one, no, principles are same. Whether there's nothing like very exclusive for psychometric studies. Because then if you go for psychometric studies, I need to know whether the person wants to go for reliability, validity or factor analysis. Then I can give the specific answer.
Okay. Like validity, reliability analysis methods. There is one more thing from Harihar Sudhan Ravichandran. I think this is the last one, sir. And now the whole workshop comes to an end. You see, I thank Dr. Lancy for his wonderful and elaborative session, which has enlightened including me also. I am very much happy about his presentation. And now, you see, dear friends, we have come to the end of the session. In conclusion, I want to communicate to you that we had 5 sessions. One is basic preliminary session, which is taken by me. Next is a little advanced session by Anurag Kurupad. Third one was for more focused session on the RGHS proposals. And fourth one was ethical considerations. Fifth one is our biostatisticians remarks and presentation. All the 5 sessions are very important for preparing the proposals for granting agency, that too specifically for Rajiv Gandhi University of Health Sciences. Here people have asked the questions regarding the attendance certificate. From our department, we will verify all these attendees and then we will issue the attendance certificate. Within 2 days or 3 days, there is a possibility of uploading the notification for inviting the research proposals by faculty people, and those people who have attended this or the previous one, if they produce the certificate, they are eligible for the submission of the articles. Probably, if everything goes like as per our own proposals, if we accept, probably the last date will be 30th June. Probably 45 days time is given for all of you. You can apply and it will be evaluated by one external, one internal evaluators. 70% marks if you score from both internal, from each, that is not average. One person, he has to score 70% out of 80 marks, that is 56 marks and above. They are eligible for the presentation. And presentation will be done faculty wise. Faculty experts will be there. Faculty dean will be there. Advanced research committee experts will also be sitting here. They will be looking into the reliability and reality of the budget, innovation. You see, if you present a PhD thesis like, or if you present any PG thesis like projects, it will not be considered. Because we give money means, or we grant money means, it should be above both of these type of research projects. That you should keep it in mind. You see, it will be very strictly evaluated. Last time, 500 and odd people have applied. Only 187 was called and only 59 were awarded. It is so strictly evaluated, and keep that evaluation criteria in mind and prepare well. I wish you all the success. Thank you for taking part in this session. In all these sessions, I thank university authorities for giving permission to conduct this session, and I thank all the resource persons, Professor Lancy and other resource persons, for their wonderful presentations. Thank you, sir. I think we will be ending the session. Thank you, one and all.